Bright Tuty. Every student matters.
Let us move to some of the examples where we can understand this introduction part very carefully. Let us move to some of the examples to understand this in detail. Let us look at this example first. Akhila went to a fair in her village. Akhila went to a fair in her village. She wanted to enjoy rides on a giant wheel and play hoopla. Right? The number of times she played hoopla is half the number of rides she had on the giant wheel. If each ride costs rupees 3 and a game of hoopla costs rupees 4, how would you find out the number of rides she had and how many times she played hoopla, provided she spent rupees 20? Now let us move to the part where it is asking the question. Akhila goes to a fair with rupees 20 and wants to have rides on giant wheel and play hoopla. Represent this situation algebraically and graphically. Okay, so for this example we just need to represent this situation algebraically and graphically. Now let us assume the number of rides as x and number of times she plays hoopla as y. Right? Now she has got rupees 20 and each ride costs rupees 3. So out of these rupees 20 she will spend some amount on rides and some amount on hoopla, and we need to represent this situation. So if the number of rides are x, so how much amount she will spend on rides? So the amount spent on rides will be equal to x into amount spent on one ride, which is rupees 3. So x into 3, or we can write it as 3x. And amount spent on giant wheel, amount spent on hoopla is equal to number of times she plays hoopla is y into the cost of one game of hoopla, which is 4. So y into 4, we can write it as 4y. Right? And this is the total amount that she has to spend. So 3x plus 4y is equal to 20 because she went with rupees 20 only. So this is how you can represent this situation algebraically. This is algebraic representation. Okay. Now if you want to represent this graphically, what will be the graph of this equation? Obviously it will be a line, right? And how do you draw a line? You find minimum 2 points, right? Because if you have got 2 points, you can find a unique line. So to find 2 points here, what you can do is you write this equation 3x plus 4y equal to 20. You make this a little table here. Okay, write x here and y here, and you need only 2 boxes because you are going to find only 2 points, right? So now if I put value of y as 2, right, in this equation, what will happen? 3x plus 4 into y as 2 will be equal to 20. So 3x is equal to 20 minus 8, that is 12, hence x equal to 4. So x will be 4 corresponding to y equal to 2. So we have got 1 point here, which is 4, 2, right? This will act as one coordinate or 1 point in 2-dimensional space, right? Why did I take y equal to 2 here? Because I knew if I take y equal to 2, it will give me 3x equal to 12 and x will be equal to 4. So it is an integral value. If I take any random value of y, let us take, I take y as 0, right? Now I didn't keep in mind to find the integral value. So what value of x will you get? When y is equal to 0, x will be equal to 20 by 3, right? Now 20 by 3 is a little more difficult than the integral point, right? Because when you represent this, or when you draw this line, what will you do? This is, let us say, 1, 2, 3, 4, 5 and so on. This is 1, 2, 3, 4 and so on, right? Now to represent this point here, 4, 2, we will go 4 steps to the x direction and 2 steps towards the y direction. So we will reach at this point here. This point is 4, 2, right? Now look at this point, 20 by 3. 20 by 3 is approximately how much? 6 point something, 6.66, right? Now to represent this point, you need to find 6.66. So what you will do is, you will mark 6 here, 7 here, and this is, let us say, 6.66 approximately. So corresponding to this, and y is 0. So this is the point that we are talking about, 6.66, 0. Okay, so it is little more difficult to represent, but now that we have got 2 points here, we can draw simply the graph, or we can represent this graphically like this: 3x plus 4y is equal to 20. So this is the graphical representation here. Otherwise, what you can do is, you can try to find another integral point and then you can see, right? Or I would suggest that you write it this point as 20 by 3, 0 to be exact, right? Because we are not going to find the exact points on this graph. This is a rough diagram, right? But you write this point exactly like this, because this is not the exact calculation for 20 by 3. Okay. All right. So this is the algebraic and graphical representation of this situation. Let us move to another example here. Romila went to stationery shop and purchased 2 pencils and 3 erasers for rupees 9. Her friend Sonali saw the new variety of pencils and erasers with Romila, and she also bought 4 pencils and 6 erasers of the same kind for rupees 18. Represent this situation algebraically and graphically. Okay. So we are given number of pencils and number of erasers. So let us consider cost of one pencil as rupees X, cost of one eraser as rupees Y. Okay. Now let us look at what Romila purchased. She has purchased 2 pencils. So how much amount she spent on pencils? On one pencil you will spend X rupees. So on 2 pencils she would have spent 2x rupees, right? For one pencil you need to spend X rupees. For 2 pencils you will have to spend 2x rupees. For one eraser you have to spend Y rupees, and for 3 erasers you will have to spend 3y rupees. So plus 3y. This is the total amount that Romila spent on buying 2 pencils and 3 erasers, and it is given as equal to 9. So this is the algebraic representation for purchase of 2 pencils and 3 erasers by Romila. Now look at the other friend here, which is Sonali. What did she purchase? See, she bought 4 pencils. So 4 pencils will cost 4x rupees, and she bought 6 erasers. 6 erasers will cost 6y rupees, and this is the total amount she spent, and which is equal to 18. So this is the representation of Sonali's purchase, right? Now we have got 2 linear equations in two variables here, and we need to represent this situation algebraically. So this is the algebraic representation. This collectively is the algebraic representation of this entire situation here. Now we need to represent this situation graphically. For graphical representation, you write this equation like this: 2x plus 3y equal to 9, and parallelly you can write this equation here, right? So we will again make that table here for values of x and y. You put certain value of x, you will get certain value of y here. So let us put value of x as 3, right? So it will become 3 into 2 6, and 9 minus 6 is 3. So y will be 1. Y 2, I put x as 3 plus 3y is equal to 9. This is 6. So 3y is equal to 3, hence y is equal to 1. Right? So this is how I get this point here. Now suggest me another value for x. If I put x equal to 0, will I get an integral value for y? Yes. If I put x equal to 0, 3y will be equal to 9, hence y will be equal to 3. So this is another point that I have got. So the 2 points that I get from this is 3 1 and 0 3. So let us first of all represent this graphically. I'll take this rectangular axis system here, right? 1 2 3 4 and so on, 1 2 3 and so on, right? Here I'll have minus 1 minus 2. In this question I don't need them. Minus 1 minus 2 and so on. This is 0, right? Now these 2 points 3 1 and 0 3. For 3 1, this 3 here and 1 here will give me this point. This is 3 1, right? 0 3, 0 and 3. So this point is 0 3, and 2 points are enough to draw a unique line. So this is the graphical representation of this line here, which is 2x plus 3y equal to 9. Now let us look at the points given by this line here. Again we'll make a table. By just looking at these two lines, you can see that if you multiply this line by 2, you will get this line, right? Because 2x here, 4x here, 3y, 6y, 9, 18 here, right? So if you multiply this equation by 2, you will get this equation. Okay, I have told you this because of the points that we are going to get here. If I put x equal to 3 here, let us say, if I put x equal to 3, I will get 4 into 3 plus 6y equal to 18. So 6y is equal to, this is 12, 18 minus 12, which is 6. So y is equal to 1. So I have got y equal to 1, which is the same point as this, right? Now again let us try this point here, x equal to 0. If you put x equal to 0 here, 4 into 0 plus 6y equal to 18, right? This will give me y equal to 3, which is the same point as this, right? So as you noticed in these two equations, that if you multiply one equation by certain constant, you will get the next equation, right? And also when you put the same values of x as 3 or 0, you get same values of y as 1 and 3. So you have got same 2 points. So what will be the graphical representation for this? There will again be the same line here, because these 2 points are the same points, and if you have got 2 points, there can only be one line which can pass through these 2 points, and this line is a unique line. Whether you write it as 2x plus 3y equal to 9 or 4x plus 6y equal to 18, the graphical representation would not change. These 2 lines are the same lines, right? So this is the case of coincident lines. which have infinite common points. Okay. So this was about graphical representation of this situation as well as the algebraic representation. This was algebraic representation. Okay, and this is graphical representation. Let us look at this situation here. Two rails are represented by these two equations. Represent this situation geometrically. First of all, always look at the equations, how they relate with each other. Now, if you look at these two equations, you will see here you have got x, here 2x, here 2y, here 4y, right? This is just the double of what we have got here. This is just the double of what we have got here. But this is not the double of this, right? You observe these lines always carefully. Now, we need to represent this situation geometrically. So, for geometrical representation, we will need the graphs of both the equations. So, let us write x plus 2y equal to 4, because this can be written as this, 4 will be taken on the right hand side. So, this can be represented graphically by finding 2 points, which is the least requirement for drawing a unique line. So, x y here, if I put y equal to 0, x will be equal to 4. If I put x equal to 0, y will be equal to 2, right. This is the fastest method of finding the points. If you put one variable as 0, you will get second variable automatically, right. Why? Because if you put x equal to 0, this will become an equation in one variable only, right. Now, another situation, 2x plus 4y is equal to 12. Again 2 points, x, y. If you put x equal to 0, y will be equal to 3. Why? Because this part will become 0. 4y equal to 12 will mean y equal to 3. 4y equal to 12 means y equal to 12 by 4, which is 3, right. And if you put y equal to 0, x will be equal to, if you put y equal to 0, this part will become 0. So, 2x will be equal to 12, x will be equal to 6 here. I have got 2 points for this, 2 points for this. Okay. Now, we have got two situations here. So, we will draw these graphs on the same graph, right. We will represent these two lines on the same graph to see what kind of lines are these. We studied 3 cases: intersecting lines, parallel lines and coincident line, right. So, this line has got points 4, 0 and 0, 2. Okay. So, what are these points? 4, 0, you will have 1, 2, 3, 4. So, this is the point 4, 0 and 0, 2, 1, 2. Okay. So, this point is 0, 2 and this point is 4, 0. Okay. And this will be the line. Now, once you draw this line, you write the equation on it. 2x plus 2y is equal to 4, right. Now, let us draw this line here. The one point is 0, 3. This is the point here. Okay, 0, 3. And another point is 6, 0. So, 5 and 6 here. So, this is the point 6, 0. So, the other line will be this, right. So, we can write the equation of this line on this line, 2x plus 4y equal to 12. Now, you notice that these two lines do not intersect anywhere, right. So, these are parallel lines. Okay. Once you do a question, then you go back to your observation that we observed that this and this was just the double of this, right, and this was double of this, and these were not following the same pattern, that is, this was not double of this. Okay. So, this is what we have observed in this question by representing it geometrically.